Patty Simpson with Simpson Math. Let's talk about the variance and the standard deviation. The variance and the standard deviation are two measures of dispersion. They tell us about how spread out our data is. And the standard deviation is calculated to help us find the average distance a data value is from its mean. So we've looked at in the past the mean absolute deviation or the MAD. And we found that actual average distance from the mean. But we also talked about at that time that absolute value wasn't fun to work with at higher levels of mathematics. Finding derivatives and such of it is not any fun or not possible. So therefore, we're going to use the standard deviation to help us with this calculation and give us an idea of that average distance from the mean. So the variance and the standard deviation are related, and in fact, the variance we will find on our way to finding the standard deviation every single time, because the standard deviation is just the square root of the variance. Our notation kind of shows that. Notice here that I have the variance, we write as, well, lowercase sigma squared when I'm talking about a population. So we write this symbol for variance squared when I'm talking about a population. I've got a census of data, but if I've collected a sample, I'm going to use S squared for the variance. Notice that for the standard deviation, it's the same symbols without the squared. And that's because the standard deviation is just going to be the square root of our variance. Then, specifically, the variance is the average of the squared differences from the mean. Let's look at the formula and you'll kind of see this in here. I'm going to show you this big scary formula. Then I'm going to do some examples to make it a little simpler and make it not so scary, okay? All right, so the variance formula here, when I have a population, I'm going to use mu, first of all, for that population mean, and I'm going to use a capital N for my population size. Remember those two symbols from when we talk about population. Then what I'm going to do is take each of my data values and find out how far away it is from the mean. I'm going to subtract them to find the differences. But instead of finding the absolute value like we did with the MAD, instead I'm going to square those distances, those differences. So we're going to find the mean of the squared differences from the mean. Now, notice with a sample, we use X bar for the mean, and we use a lowercase n for the sample size. But notice that the formula is actually a little different. With the MAD, the formulas were exactly the same, but with the variance and the standard deviation, our sample formula is a little different. We're actually going to subtract 1 from our sample size when we're finding that mean. And the reason this adjustment's made in the formula for sample variance and for sample standard deviation is to account for the fact that the sample variance and the sample standard deviation is a biased estimator of the population variance. So I know this is a lot and it's really kind of overwhelming. So let me simplify it a bit by just doing a couple of examples. It will really help, and maybe it'll help ease a little bit of your anxiety over this whole thing. So it's a lot like finding the MAD, the mean absolute deviation, except instead of finding that absolute value, we're going to square some things instead. So let me give you some data to start with. First, Newman has 4 dogs. Newman has 4 dogs. And he weighs the 4 dogs and collects the data on those 4 dogs. So in kilograms, there's 6, 5, 17, and 8 kilograms. And we're going to find the standard deviation of this data. Now, Typically, we're working with larger data sets than what I'm going to do, but I'm going to simplify it, hopefully to help you understand it better, and also just to make it a little bit easier for us to see what we're doing. Okay, I'm going to do the same thing that I did with the MAD, where I make myself a table to help me along the way. So I'm going to make a table of my values. I'm going to start by just telling myself what those different little data values are. So I have 6, 5, 17, and 8. Then the next step is to find the difference between that and its mean. Now, a couple of things I should have started with. Number one, we have to decide, is this a population or a sample? Well, he has 4 dogs, and we've collected the weights on all 4 dogs. So this is a population. It's really important when we're figuring out variance and standard deviation to know where our data comes from. In this case, we collected a census from our whole population. That's going to be important in the end. So then, when I'm talking symbols, because it comes from a population, we collected a census, I'm going to use mu here. So I'm going to subtract my mean. Now, in order to do that, first I need to find that mean. So I need to back up a second and find the mean of my data. So my data is 6 plus 5 plus 17 plus 8 divided by however many I have in there. So I'm just finding the mean of this data. Where in the center of this data is that mean? So here I have 11 plus 17 is 21, 28 plus 8 gives me 28 plus 8 is 36 divided by 4. So my mean is 9. So in order to be able to find the differences, I have to do that first. So first we decide actually, is it a population? Did we collect a census or a sample? Then we're going to find the mean of our data. Now I can find the differences between my data values and that mean. So 6 minus 9 equals a negative 3. 5 minus 9 equals a negative 4. 17 minus 9 equals 8. And 8 minus 9 equals negative 1. Now, just like with the mean absolute deviation, just like with that MAD, if this really is the mean and I've done my subtraction correctly, then this should add up to be 0, because that's how the mean works. So let's add it up and see if it equals 0. Negative 3, negative 4 makes negative 7, and a negative 1 makes negative 8. Add that to a positive 8, and sure enough, you have 0 in here. So we can't find the average of that because it equals 0 every single time. So with the MAD, we made it positive by finding those distances. But again, absolute value is no fun to work with. So instead what we're going to do is we're going to square these guys to make them all positive. So I'm going to take each one of these values and square them. And it's going to make them all positive. Because when I square a value, a negative times a negative makes it a positive. So negative 3 times negative 3 is 9. Negative 4 times negative 4 is 16. 8 times 8 is 64. And negative 1 times negative 1 is a positive 1. So I'm squaring each one of those values. Now, I'm going to find the average of these. So here's what I've done so far. I took and found these differences. I squared them. Now I'm going to add them all up and divide by the number of data points that I have. So I'm going to add these all up. So 25, 26, 26 plus 4 makes 30, plus 60 makes 90. So when I sum them all together, this is the sum of all those differences squared. Now I'm going to take that and divide it by the total number. So I'm going to divide that by the total number, which is 1, 2, 3, 4. And that's going to give me my variance. So 4 goes into 9 2 times with 1 left over. 4 goes into 10 2 times with 2 left over. 4 goes into 20 5 times. So the variance of this data is 22.5. The smaller that variance, the less spread there is in our data. Now, to find the standard deviation, all we do is take our variance and take the square root of it. So this is the variance. We have found our variance. To find the standard deviation, we just take the square root of that. So the square root of 22.5 is our variance. Now this is in exact form. We have found it in exact form. If we wanted to approximate it, remember that we know how to approximate. We know that this is less than the square root of 25, but more than the square root of 16. So it's bigger than 4 and less than 25. So it's 4.7-ish. The standard deviation, the average distance that a data value is from its mean is about 4.7 units away. The standard deviation is going to be really, really important throughout this entire course. We're going to find and use that standard deviation over and over again. Let's do another example. So this time we've got Justin in his push-ups again. Justin does push-ups every day for a month. Justin does push-ups for a month. But he only records the push-ups he does on Mondays. And here's his data. He has 21, 24, 27, and 29 push-ups that he does on those Mondays. And we're going to find the variance and the standard deviation of this data. Now, the very first thing we do is decide, is this a population or a sample? Well, he didn't get all of his push-ups written down. He just did the ones on Mondays. So he didn't collect from all the days. He just did a part of it. So this is a sample. So a couple of things that tells me. First of all, when I'm using my notation, I'm going to use X bar. I'm going to use S and S squared for variance and standard deviation. I'm going to use N. And at the very end, when I'm dividing, I'm going to divide by N minus 1. That's going to be really important that within that, at the very end, I'm going to divide by N minus 1 instead of by N. Now, I'm going to make my little table. Well, before I do that, step 1 is to find the sample. Step 2, I need to know the mean. Since I'm trying to find the average distance from the mean, I've got to find the mean. So I'm going to find the mean of this data, my X bar of that data. So I'm going to add up all my data values and divide by the number of data values I have. So 1, 2, 3, 4, 5. So notice here I'm still dividing by 5. I don't do the N minus 1 till I get to the very end. So I add all this up. Well, that's 5, 9, 16, and 9 is 25. Carry your 2, 2, 4, 6, 8, 10, 12. 125 divided by 5, that goes in there 2 times with 2 left over. 5 goes into 25 5 times. So our average there, our mean is 25. And we want to find the distances or the differences between that 25 and our data values. So I'm going to take all my data values and write them down, 21, 24, 24, 27, and 29. And now I'm going to find those differences between that and the mean. So 21 minus 25 is a negative 4. 24 minus 25 is a negative 1. 24 minus 25 is a negative 1. Notice I'm just doing the mean every time here. So minus 25 is going to be there every time. And then this is just my data values. So that's 2, 4. Now, I'm going to, if I've done it correctly up to this point, this should add up to be 0. Let's check it. Negative 4 and a positive 4 make 0. Negative 2 and a positive 2 make 0. So sure enough, that makes 0. Now, I'm going to take each one of those values and I'm going to square them. So negative 4 squared is 16. Negative 1 squared is 1. Negative 1 squared is 1. Positive 2 squared is 4. And a positive 4 squared is 16. I have now found my differences between my data and the mean, and I've squared those differences. I'm going to find the average of that. So I add up all those values. So now to find my, using an S, use an S, and to find the variance, so that S squared is variance. So to find that S squared, I'm going to add those all up, 16 plus 1 plus 1 plus 4 plus 16. But instead of dividing by n this time, I have to divide by n minus 1. So my n is 1, 2, 3, 4, 5. I'm actually going to divide by n minus 1. 5 minus 1, or 4. We add those up together, and we get 17, 18, 22, 32 plus 6 is 38. Divided by 4. Well, 4 goes into 38 9 times with 2 left over. So 4 goes in there 9.5 times. This is the variance. We have found that variance. I now take that and find the square root of it, and I have found my standard deviation. So the square root of my variance is that standard deviation. If I compare these two standard deviations, the square root of 22.5 and the square root of 9.5, I know that this data has more variability. It's more spread out than this data is. This data is closer together. So that's what the standard deviation tells me, is it tells me about the spread of my data. Math Made Simple is Simpson Math. Thanks for watching.